All right, Sarah and Cray, I'm going to see if this video will stick this time. We are on the backside of 5.4 notes, and we're talking about the graph of a log and an exponential function. So we went ahead and graphed y equals 10 to the x power. We said he looks like this, okay? Every exponential function will look something like that. Then the log function will look like this guy. He'll intersect over here at 1, and he will have a vertical asymptote. Just like that. Okay, do you guys remember yesterday when we were trying to find log of like -3 and you had to type it into your calculator? Do you remember what happened?
It was error.
Okay, log of a negative number. You can't have it because look at the graph of a log. This guy over here, he does not have any negatives. He's never over here on this side, right? So that's another example of why negative numbers don't work in logs, right? Okay, so a log function looks something like that, all right, until we move him around. Okay, until we move him around. This dotted line right here, what did that mean again?
That's the thing.
That's the line. So, a log function and an exponential function. These two are inverses of each other right here. This guy and this guy are inverses, and when they're inverses, they reflect across this dotted line. So that's kind of how that works, okay? Let's go down to this example. If our parent function is just log x, this is the parent guy. Okay, what does the -3 do, and what does the 2 do?
Moves in.
How does it move in? Let's. Which one is doing first?
The right.
The -3 is the first thing that happens. Okay, how does that move it?
Right.
To the right. Valerie's dying over there. To the right 3 because it's the opposite symbol. Put your phone away, Amicar. To the right 3 units. Okay, what does the 2 do? He's a vertical stretch by
a factor of 2.
a factor of 2. So if I graph this guy to find the domain and range,
He's gonna be stretched out.
he's going to be over here to the right 3 units. That's where my vertical asymptote's going to be now. And he's going to be stretched. So he's going to be a lot taller. So rather than curving right away, he's going to stretch up and be a little bit taller than what he was before. That's what he's going to look like. Okay, this is my log function. Where is it intersecting right here? Where is this point?
Yep.
That's the answer.
No, where is he touching right there on the x-axis? Where is he touching there? 4. He's touching there at 4, right? Because he's usually at 1 is where he's touching, right? But if we're shifted over 3, that guy will be at 4, right? Okay? All right, my vertical asymptote is at x equals 3 because that's where he's shifted over at. And now we have to identify the domain and the range, okay? Domain is the x's, which are left and right. Will he go to the left forever?
No.
No. Will he go to the right forever?
Yep.
Yes. So he has only x's that are
Greater than 3.
greater than 3. Is he equal to 3? Is he touching 3 exactly?
Nope.
No, because there's a vertical asymptote there, right? Okay. Range, up and down. Will he go up forever? Yes. He'll go up forever, right? This is going up forever. Will he go down forever?
Yep.
Yes. So what do I do for range?
All reals.
All reals. For a log function, your range will always be all reals. Okay, your domain will always be something different. Okay?
Water back.
What? ln is the same way. Okay, ln is just a base of e rather than, so it's just when your base is changed, it just changes like it's like a vertical stretch, kind of. Like how curvy it is. It'll still intersect at 1, or in this case 4, but it still does the same thing. Yes, ln is a log, right? Okay, moving on. Let's go down here. This one is an ln. Okay, example 6. This is my parent function. We're starting with ln, which is still a log function. You got to listen.
Listening.
Okay, parent function is still ln.
Horizontal stretch.
Okay, I don't like the way that they wrote this thing. I'm going to rewrite it different before we start to dissect it. 2 minus x.
It's down.
X minus 2.
No,
X plus 2.
negative x plus 2.
Yeah.
Okay, I like to write it with the x going first. How many things are happening to it?
3.
1, 2, 3.
It's going left too.
Okay, no. Wait, which one's happening first?
The negative.
The negative. If you were to plug a number in for x, you would apply the negative first. Okay, what's that negative do to it?
Over y.
Over the y. Yep, over y. Okay, what's the plus 2 do?
Left 2.
To the left 2. Okay,
Down 3.
that's the plus 2. And then minus 3 is down 3.
Oh my gosh.
Okay, all right. Okay, follow along. This one's trickier. Okay, normally I'm going to do just a really faint line of like the normal function. Normally he intersects over here at 1. Doesn't matter that he's ln versus log. He's still going to do something like this, right? This is what he looks like. Okay, that's what the ln function looks like normally. Okay, now we're going to flip him over the y-axis. So I'm just going to follow along with this dot. This dot is going to be here, right? Okay.
Yeah.
Now that dot, my vertical asymptote's still in the same spot. So now I have like something like this going on. Don't draw that yet. Watch me, don't draw yet. Okay? That's where we're at now. After I shift him to the left 2. Left 2. Now where is this dot at? Right here. That's at -3. Where's my vertical asymptote at now?
2.
At -2 right here. That's where he's at because we're going to the left 2. Now if I go down 3. Now this dot is down 1, 2, 3. So this is my final resting place of my dot there. Where is that coordinate? -3, -3. Where's my vertical asymptote? Still at -2. Moving it down doesn't move the vertical asymptote, right? Okay. So we've got that, and this is my final guy right here. He's doing something like that.
That's what I got.
Yeah?
Well,
Okay.
you're just a different word back there.
And there's my vertical asymptote, so he's doing that. Okay, so that final guy is there. We want domain and range. Domain, range. Domain is the x's. Will he go to the left forever?
Yeah.
Will he go to the right forever?
No.
No. X's that are strictly less than what? -2.
Yeah.
Will he touch -2?
No.
No, so it's not equal to. So x's that are less than -2 range, up and down?
Oh,
All reals. Beautiful. Okay, happy with that?
Yep.
It helps to draw a picture before you do domain and range. You'll have to do that in your homework assignment. Okay, good? I don't give you a graph, but it helps to draw just a rough sketch. So I will not grade your sketches, but please kind of sketch it a little bit so you know what's going on. Okay, example 7. This is the last one. We're going to actually solve something. So do you remember before when we would have story problems in section 5.3 in the last section where we would have to get on your calculator and use the table and to like guesstimate what year it occurred?
Yeah.
We're going to find out exactly what year it is now. Okay, here we go. If you invest money at an interest rate R compounded annually, blah, 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 it takes time to double. So this is the stuff right here. Okay, R is the interest rate. And D is the time in years that it would take to double. The time. Okay? How long would it take to double an investment of that much at 6.5% annual interest? Okay, what's 2,500?
A. Or P.
P. Where is P located?
LN.
Why don't we have a P?
Okay.
We don't need it.
Why don't we need P?
Because
we don't
We
care.
already went to the bathroom.
It's
Okay,
gonna
great.
not matter how much.
Right. You guys had a problem in section 5.3 that tested like 3 different price values or 3 different amounts. And the amount or the amount of time that it takes for $1 to double is the same as the amount of time it takes for $50 to double, which is the same as the amount of time it takes for $1 million to double, right? Yeah, this was on your homework. So it doesn't matter how much I'm investing to start with.
Speaking of homework, I need
We just, it just depends on the interest rate, okay? So 6.5%, 6.5% goes in for my interest rate, and we're going to figure out how long. So we're just finding the DR, and that's ln of 2.
first and middle.
This is just, we're plugging this in. 1 plus, but the interest rate is 0.065, right?
So can we just plug that in?
You can just plug that in. So ln of 2 over ln of 1.065 if you want to just put that stuff together. What does that come out to be? How long is it taking this thing to double?
11.0067.
11.01.
067.
11.01 what? It doesn't. No, not in this case. Not in this case. Years.
11.01, yeah.
It's taking 11 years before that investment doubles. So after 11 years, I have $5,000. If I would have invested, let's say I invested $10,000, it would still take 11 years at that interest rate to double to $20,000, right? So
my nieces and nephews
You think
Are
Kate's gonna
born.
have kids?
are born, I'm gonna give them $10,000, and then by the time they're 11,
okay, but Kelsey Carr,
You're
Kelsey
gonna
Carr.
give him
Kelsey Carr, you will be hard pressed to find Kelsey Carr. Kelsey Cometer. You will be. You will be. I'm trying to combine your names. Anyway, you will be hard pressed to find 0.6% interest, let alone 6% interest.
Kelsey Carr.
Kelsey Carr is not
Kelsey
that
Carr.
smart.
Great.
You definitely should not call Kelsey Cometer Kelsey Carr. She's
Yeah,
not
yeah.
the smartest.
Casey Meyer, put your phone away. I'm not dumb. I know what you're doing. Put your phone down. You don't need to watch that. No, you don't. No, you don't. D or B. B. I could just take it away and you won't watch it the rest of the day. That's a thing too. B. What annual interest rate? Put it away. Flip it upside down. Okay. What annual interest rate is needed in order for the best investment to double in 6 years?
Now we're just.
LN of 6.
Now we're finding.
LN 6.
No,
Now we're
6 is the
finding-
B.
Why?
6 is the D of R, right?
R.
Okay, now let's talk about this real quick. If we're doubling in 6 years, do we need a higher interest rate or a lower interest rate?
Lower.
Higher.
It's got to be a lot higher because it's doubling faster than 11 years, right?
Oh.
Yeah,
I
6
thought
years.
that was 2
It's got to be a lot higher. So 6 years is my
D.
D sub R, the D equation, whatever that is, and ln2. We're gonna plug that in. ln of 1 plus. We don't know the interest rate, so we're gonna leave it as R. And now we're gonna solve this thing. Okay. So we need to get the R out of the equation. We need to get the R figured out.
Multiply the whole thing of
Okay.
the bottom.
We're gonna multiply the whole bottom over to the other side. Okay.
6
Great.
and
ln of 1 plus R. That's now to the other side. Okay. Now what?
divide. No. Take the ln over 2.
So now I'm gonna put the 6 in front. I've got 6 ln, 6 ln of 1 plus R. This is what we have, equals ln of 2. If you can't like see what's going on, rewrite it so it's not as so messy. Now what?
Divide by LN.
Okay.
The 1 plus R is stuck inside of the ln, so you can't just divide the ln over.
Can we divide that ln2?
Fine.
Get rid of that.
Go leave.
Get rid of
Make the
six.
6 go away.
Get rid of the 6. Let's divide the 6 over.
I just
Right?
put
He's
that
gone.
one.
Divide the 6 over. Okay? All right, here we go. So we've got ln of 1 plus R. And then can you get a number from ln of 2 divided by 6?
Yes.
Okay, if you're going to type this into your calculator, make sure, like, if you don't put it as a fraction, you close the parentheses after the 2, right?
0.1155.
0.1155. Okay, great. All right, now what? We have an ln and we're trying to figure out what it is. We have an ln and we're wanting to get rid of it.
Distribute it.
No. How did we solve them? How did we solve in the first part of this chapter?
Oh,
we
put
have
it
to
as a
put-
log.
Make it as a, it's already a log.
Or yeah.
Make it an exponential function. So this is log base e to start with, right?
So it's
So e to the
0.1155
equals
1 plus x.
1 plus r, 1 plus x, right? Okay? All right, what is e to the 0.1155?
No clue.
Approximately 0.11.
These are going to be really low decimal numbers, by the way.
1.1224.
1.1224. Okay, then what?
And then -1.
Minus 1. So that is, don't do that in your calculator.
0.1224.
0.1224. What does that mean?
That's the interest rate.
The interest rate. The interest rate
12%.
is 12.24%. Is that what we guesstimated?
Yeah.
We said it had to be higher than what it was before. It was 6.5% before. Now it's 12%. If we want it to double faster, we've got to increase the interest rate. Does that make sense?
Yeah.
That's exactly what it is. We're no longer looking it up on the table anymore. We can find the exact one, right? Okay? All right, you guys have this homework assignment. Do
No, I
not.
know. I
Yes, you do.
No, I don't. I don't.
You were here yesterday.
I know, but I lost
I just
it.
there for like 3 minutes and my paper was flipped over.
So-
and
Alright.
Suddenly we're done.
Everybody else get to working on
That's
this so you can
so
ask me
weird.
questions. We're going to move on tomorrow.
Can I
Bye,
have
people
another?
watching this video.
Do you have another?
Oh,
I was like, huh, she's done already? She didn't have a question on the last one?
Do you have another one?